here we are going to discuss. So here we are going to discuss the first Olympiad challenge. Through this, we will also discuss another question. In the Olympiad challenges, you can also propose your own questions and send us the solutions. To that, we would be happy to post this as in this section. You'll get more details in the description box. So, what's the question? How many northeast lattice path? First of all, there are a few things that we'll learn through this question. That what is lattice path? How to count the number of lattice path? And obviously how to solve this type of questions and what are some other ways in which these questions can be changed and application of this lattice path. So how many northeast lattice path? Consider the shortest path are there from 3,2 to 18,14, which doesn't cross the green line. However, it can touch the green line shown in the figure. Okay, so let us focus on the first part. How many northeast lattice path? So what's the definition of lattice path? See, this is the definition of lattice path. For integers in a coordinate plane, this is the y-axis, this is the x-axis. There are some integral point, say x1 comma x2, and our destiny is some y1 comma y2. A northeast lattice path. Denote a northeast lattice path to be a path consisting of unit steps north and east. What do I mean by unit steps north and east? See, this is a grid. We have the grid lines clearly visible, and this is a 1 2 3 4 5 1 2 3 4. This is a 4 into 5 grid. 1 2 3 4. Fantastic. From 0 comma 0 we want to go 5 comma 4. The basics of lattice path we are discussing, because without this we won't be able to solve the question. So what does northeast lattice path and shortest lattice path means? Here northeast lattice path means we can either go in the north direction, this is the east direction, this is the north direction. That is, we can either go upwards or rightwards. And if you observe it clearly, that any path, anywhere that we are going through, say this is a path, say this is a path, this path, okay. See how I am going to my destination from 0 comma 0. First, this is east direction. Then sometimes I am going through north direction and sometime again east directions. Sometime north and sometime east. How many east are there? Let me count one east as one unit east. Let one E denote one unit east. That is from 0 comma 0, 0 comma 0 to 1 comma 0. We can say this is 1E. 1E. So how many E's are there? You see. East, east. Now 2 units north. Then again 2 units east. Two unit north, and last 1 unit east. So this is the path. Now how many such paths are possible? If we draw any path, let it be any path, that doesn't matter. What is the total number of east? There should be minimum 5 east. We're going from 0 to 5, so there are 5 unit east and 4 unit north. Now all of this path, whatever we are drawing, are just the arrangements, different arrangement of this e's and n's. So how many arrangements are there? With the simple idea of permutation with repetition, we have 9 factorial by 5 factorial 4 factorial. That's the number of path, and that's the concept of shortest lattice path, or you can say northeast lattice path. Now why I'm saying the shortest lattice path? Fantastic. Why shortest lattice path? See, I can have a path like this. I can have a path like this. No, this is obviously not a shortest lattice path. Why? Why? Because here you can see that I am going 1 unit south, again here 1 unit south. 2 south are extra. So obviously to balance them we need 2 north extra. So this is not a shortest path. In some questions, in some special kind of questions, they will give us the path length. Here, what is the path length? It's 5 plus 9. 5 plus 4 is 9. This is the path length. But suppose the path length was given as 14. In that cases, we need to think of such kind of path. Such kind of path, where the path is not the shortest path. Okay, that's a different thing. Quite easy thing. We need to just go for some case analysis and then apply permutation with repetition. So in this way, we'll find the number of path. Now let's go to our original question. Now northeast lattice path is very clear to us. How do you find the total number of path from 0, 0 to some line to some point in the coordinate plane is also clear using permutation with repetition. Some case analysis, that's it. Now we want the paths from 3, 2 to 18, 40, which doesn't cross the green line. What's the green line here? See, this is the green line, okay? This point is 3, 2. This point is 3, 2, and this is 18, 14. Which doesn't crosses the green line. However, it can touch the green line. Okay, fantastic. Let me show you one illustration. You'll be able to solve that question yourself. This line is not crossing the green line. Fantastic. Now another example of line that doesn't crosses the green line. See, it just touches the green line, but it doesn't crosses it. It can touch, is given in the question. However, it can touch the green line. Okay, fantastic. So these are valid paths. Okay. So how to find the number of paths which are valid? Here, this is a very large number from 3 to 18. I won't be able to draw it very clearly. We need small case analysis to understand it in a better way. Let me go to my original lattice path. Okay, here we can explain it. Say 4 into 4 grid. 1 2 3 4 5. Okay, 5. 5 into 5, great. 1 2 3 4. Okay, 5 into 4, that's good. From 0 comma 0. Okay, let me change it a little bit. From 2 comma 2. 1 2 3 4 5. 7 comma 2. 7 comma 2. 1 2 3 4. 7 comma 6. I'm just changing it, I'm modifying it a little bit so as to have more proper understanding. Now, let me draw any line. Let me draw the diagonal. That would be a better. Okay, it cannot have a diagonal passing through because it's not a square grid. Fantastic. No issues. Let me draw this. Fine. Now, we need to find the number of path which doesn't crosses the given red line. How would you find? Uh, let me draw some valid paths. Okay, this is a valid path. What are the total number of paths without any restrictions? How many east are there? You can say east or you can say right. 7 minus 2. We're going for the shortest path, obviously. 7 minus 2, 5 east. 5 east. And 6 minus 2, 4 north. So the total number of path is 9 factorial by 5 factorial 4 factorial. Now we can find the number of path. There's a trick to find the number of path which crosses the line. And we'll simply subtract it in order to find the number of lines which doesn't crosses the given line. Now how would you find the number of lines that crosses? Let me draw a simple path which which crosses the given red line. Okay. Now it crosses the given red line. Let me draw another path. Fantastic. Now what is the criteria for crossing the given line? For crossing the given line, it should rise up at least a point above the given line. It should rise up at least 1 unit. It should rise up at least 1 unit above the given line. Then only it will cross. Am I correct? It should rise up. It should rise up at least 1 unit. At least 1 unit above the given line. So we're discussing this. Sorry for the interruption. From 2 comma 2 to 7 comma 6, the number of paths, we have seen the minimum criteria for the paths from 2 comma 2 to 7 comma 6, which just crosses this red line. Which just crosses this red line. Okay, it's not red. That's not a great deal. I do not know what the color is. Is that it should go at least a unit above this line, a unit length above this line. That means all the path which crosses this red line should cross this line or at least touches this line. Let me draw it with a different color. All the path which crosses this red line should at least touch this blue line. At least touch this blue line or cross it. Now let me extend this blue line and you will see the magic of lattice path here. Let me draw the reflection with the different color, say red. Let me draw the reflection of this part. From where it touches the blue line, we'll draw the reflection. From the point where it starts touching it, of this line, okay, we'll draw the reflection of this part. 1 unit, this is 1 unit east. Its reflection or complement, you can say, would be 1 unit north. 1 unit north. Again 1 unit north. Again 1 unit north. Let me extend the lattice. Okay. So this is the reflection of this point, we can say, about the blue line. Now we'll go 1 unit up and its reflection will be 1 unit right. If we can observe one thing, that the reflection of 7,6 is this point. It is our destination. Let me mark it with green and let me mark it with green. It's our destination about the blue line. Now, one thing that I want you all to confirm is that the reflection of a unique person, two person, say A and B, are standing in front of a mirror. In front of a mirror. Now, the reflection of A is unique. Is it like that? If the persons are unique, then the reflections are also unique. That means if the path are unique, the reflection of the path are also unique. If the path are unique, the reflection of the path are also unique. So all the path which touches this line are actually crossing the red line, which touches this line are actually crossing the red line. And since their paths are unique, the number of lines, we can say, the number of lines which are actually crossing the given line is what? Simply the number of path from 2, 2. You can see one thing. I know it's a little bit confusing here from this part. This was our original path, right? Now, the reflection of this path from this point goes here. If we draw another path, let me remove the unnecessary drawings in order to make it a little bit more visible. Now let me draw another path which just crosses this line, or not just, which crosses the red line. Let me take a different color. See, it has crossed it successfully. Fantastic. It has crossed the red line successfully. Now at the point where it touches the blue line, let me draw its reflection. Where will its reflection go? The reflection of this part is simply here, and this is the destination of reflection. Now if we see that how many such reflected paths are possible, we can clearly observe one thing, that this black line starts from 2, 2 and ends at where? 7. This point is what? 6, 5, 5, comma. This point is 5, comma 8. All the lines which are crossing the red line, if we draw its reflection on the blue line, that is the line just above the line, above the red line, then they end up at a unique point, and that unique point is simply the reflection about this line, reflection about this line. Because see, this is another path, this black path is also going to 5, 8. So the number of path which crosses the red line, number of path which crosses the red line are simply the number of paths from 2, 2 to 5, 8. And how many paths are there which crosses the red line? The number of path from 2, 2 to 5, 8. That is 2 plus 5, 7. Sorry, 1, 2, 5. Number of path from 2, 2 to 5, 8. How will we find it? Three unit right, or you can say 3 unit east, and 6 unit north. Number of paths are 3 plus 6, 9 factorial by 3 factorial, 6 factorial. So these are the number of path which is crossing the given red line. And if we subtract it, we'll get the number of line which doesn't crosses the given red line. And this is our result. We'll simply use this result. We'll simply use this result in this question. We'll find the reflection of this 18, 14. We will find the reflection of this 18, 14. We will find the reflection of this 18, 14. With respect to what? The line just above the given line. The line just above the given line. Okay. I do not know what's the reflection. You'd find that reflection, say this reflection is some a comma b. Say that reflection will be some a comma b. So you can find the number of path from 3, 2 to a comma b. Find the number of path from 3, 2 to a comma b. And the total number of path from 3, 2 to 18, 14. Total number of path from 3, 2 to 18, 14. Minus, I would say, reflected path. Minus reflected path. You'd get the number of lines which doesn't crosses 18, 14. That's the basic fundamental of this question. Using this idea, you can solve this kind of problems total minus reflected. Now, using this concept of this total minus reflected and this reflection and all other things, a very nice question was given in the test.